My name is Muhammad Al-Hakim bin Fazil with matrix number 2025379589. Good morning everyone. Today we're diving into the fascinating world of cache memory, specifically the Associative Cache Organization in the Intel Celeron N3000, a dual-core processor from the 2015 design for low-power devices like laptops and mini PC. Cache memory is crucial. It acts like a super fast bridge between the CPU and the slower main memory, speeding up data access. The Celeron N3000, with its 2 MB cache and up to 2.08 GHz clock speed, uses an associative cache design to optimize performance in its multi-core setup. This design allows flexibility, data storage, reducing delay and boosting efficiency. Our presentation will explore how this cache works, its structure, and what is matter for our modern computing. By the end, you see how smart cache design power even entry-level device. Let's hand over to our next presenter to break down the organization of the cache system. Thank you.
Hello everyone, my name is Muhammad Uzair and I will start the first half of the cache organization in the Intel Celeron N3000. And Intel Celeron N3000, a dual-core processor that punches above its weight thanks to its clever cache design. Cache memory is the CPU secret weapon, acting like a high-speed notepad that keeps frequently accessed data right next to the cores, slashing the time it takes to fetch data from slower main memory. Without cache, your apps will crawl in a multi-core system like the Celeron N3000. The cache is organized into two levels, L1 and L2. L1 is dedicated to each core, split into separate caches for instruction. Think of this as the CPUs to do this, and data, like the numbers or text you're working with. L2 is a larger shared cache that both cores can access when L1 doesn't have what they need. Now, let's talk specs. The L1 instruction cache is 32 kilobytes per core and 8-way set associative, meaning each piece of data can be stored in any of 8 slots within a set, like choosing one of 8 lockers at a gym. The L1 data cache is 24 kilobytes per core, 6-way set associative with 6 slots per set. This associative design is a game changer. It reduces cache misses, where the CPU has to wait for data from main memory, which is like waiting for a delivery instead of grabbing something from your desk. For example, when you're gaming or streaming, this cache keeps critical data ready, ensuring smooth performance. The magic happens through set associative mapping. Main memory is divided into sets, and each set has multiple lines. Each line stores data plus a tag, which is like a label to match the memory address so the CPU can quickly confirm it's got the right stuff. Compared to direct map caches, where data has only one possible spot, this flexibility boosts efficiency. Alright, I will pass it to my colleague to dive into the L2 cache and multi-core perks. Thanks.
Okay, I'm picking up with the second part of the cache organization. The Intel Celeron N3000 L2 cache is 1 MB per core, 16-way associative, and is shared between both cores. This high associativity, which is 16 possible slots per sec, further cuts down on a data access conflict. When the cache is full, it uses a replacement policy, likely least recently used, to swap out data smartly. Now, why was this matter for a multi-core system? The L1 cache gives each core fast, dedicated access for independent tasks, like running different apps. The shared L2 cache ensures data consistency when both cores work together, like in a multi-thread programs. This setup boosts performance while keeping the power low. critical for the Celeron's forward design. Imagine it like a very well organized library. L1 is your personal desk, L2 is the shared stack, and associative design is the smart catalog system. Together, they minimize delay and save energy, making this processor efficient for budget device. Let's write it up with a summary. Thank you.
I'm Muhammad Izdian. I will recap what we have learned today about Intel Celeron N3000 with a focus on its cache memory system. Even though this processor is designed for low power, especially in budget-friendly laptops, it actually uses a smart and efficient cache architecture that really boosts its performance. Its cache includes 32 kilobytes 8-way L1 instruction and 24 kilobytes 6-way L1 data cache, plus a shared 1 megabyte 60-way L2 cache. This set associative design that data maps to multiply slot, reducing misses and speeding up access compared to basic cache. In a multi-core setup, L1 cache full fast and independent tasks, while L2 ensure core share data efficiently. This balance keeps the processor smooth like butter just forwards, perfect for affordable laptops. The Intel Celeron N3000 show how clever cache design drives modern computing, even in entry-level chips. Looking ahead, bigger or smarter cache could push performance further. So, what does this mean in real-world use? The Celeron N3000, despite being a basic chip, performs quite well in lightweight computing like browsing, media, or schoolwork, thanks to this well-balanced cache structure. It's energy efficient too, using only about 4 watts of power. That's really low, and it's one of very few reasons why the device using this chip has longer battery life. To put this all together, the cache system in this processor with fast L1 cache for performance and smartly share L2 for collaboration is the key reason why it works very smoothly without needing a lot of power. Like wise people always says, more not necessarily better. So even though this is entry-level CPU, Intel masterpiece engineering design proved that efficiency doesn't always need high specs. Sometimes it just needs smart architecture and optimization. That's only from us. Thank you for listening.